Let's learn how to draw Lewis structures by starting with the simplest possible molecules. These would be diatomic molecules. Here's a good strategy that you can follow for diatomic molecules. First, you connect the two atoms with a single bond. So, for example, let's say you want to draw the Lewis structure for carbon monoxide. You connect the carbon and the oxygen with a single bond. Okay? Then you add lone pairs to complete the octet on each atom. So if I want an octet on my carbon, I already have a pair right here with a single bond. I need 3 more lone pairs. So 1, 2, 3. So you can see your carbon atom has 1, 2, 3, 4 pairs of electrons around it. So your carbon atom has an octet. Okay? And we do the same thing for the oxygen. I need to add, it already has a bonding pair, so it needs 3 more pairs. So I need 3 lone pairs to add to the oxygen. 1, 2, 3. Okay, so both carbon and oxygen have an octet. Now, let's verify to make sure that this is consistent with the number of electrons that's actually available. Okay, remember, we should have done this first. Carbon contributes column 4, has 4 valence electrons. Oxygen is in column 6, it has 6 valence electrons. So carbon monoxide should only have 10 valence electrons. Well, so let's count how many electrons do we have in the structure and see if it's consistent with the number of electrons that we should have. So let's see. This is 2, 4, 6, 8, 10, 12, and then 1 more in the bonding pair. That's 14 valence electrons. So that's not right. Okay, so that's the wrong structure for carbon monoxide. So when that happens, what does that tell you? That means this structure, if you want to have single bond between carbon and oxygen here, you're going to need 14 valence electrons. You don't have 14 valence electrons. You only have 10. If you don't have enough, then you do more sharing. Okay? So if you do more sharing, what you can do is you can remove a lone pair from each of the 2 atoms. So I'm going to take out 1 lone pair here and 1 lone pair here and add a bonding pair between them instead. So I now have a double bond. See, I remove 2 pairs and then I replace it with just 1 pair. That's a bonding pair now. I remove 2 lone pairs. But if you look at the structure, it still has an octet on the carbon. Look at the carbon. You have 2, 4, and then that double bond makes 6 and 8. I have an octet. Oxygen still has an octet. Okay? You have 2, 4, and that double bond makes 6 and 8. So let's see if that works now. Well, think about it. You're replacing 4 by 2, so that only drops down the number of electrons shown by 2, right? So let's count it. 2, 4, 6, 8, 10, and 12. So you have 12 valence electrons. That's still not correct. We should only have 10, okay? So that means we need to do more sharing. And so the next thing we do is take out another pair of lone pairs. So I take a lone pair from the carbon, this lone pair, and take another lone pair from the oxygen, that lone pair, and replace those 2 lone pairs by another bonding pair. So now you have a triple bond between the carbon and the oxygen. Okay? And 2 lone pairs, 1 on the carbon, 1 on the oxygen. So let's verify if we still have an octet. That's 2 and plus 6, 3 pairs, that's 6. So that's an octet around carbon. Okay, so as far as this carbon is concerned, it's surrounded by an octet. And then the oxygen has a lone pair and a triple bond next to it, so it's surrounded by an octet. And let's verify that we have, in fact, the right number of valence electrons shown now. You have 2 right there, 6 in the triple bond, and another 2 in the lone pair. 2 plus 6 plus 2. That gives you 10 valence electrons. So the Lewis structure for carbon monoxide is one where you have a triple bond between the carbon and the oxygen, a lone pair on the carbon, and a lone pair on the oxygen.